Okay, welcome to another video. Now ideally you should be coming from the previous video, then you should watch this video as a part 2. But if you're new, that's totally fine. We're going to speak today about domain and range, sort of a part 2 of the previous video. But specifically, we're going to speak about notation, different ways of writing domain and range. We're going to do that by going through examples. Now let's return to the example from the last video. In the last video, we faced this function here, the quadratic. Typical quadratic, very basic, the parabola. And we found by looking at the x-axis and seeing what parts of the x-axis this parabola covers, and we found that the domain, so we could write D, is x belongs to real numbers. For all x that belongs to the real numbers, this function has outputs. So there's no restriction, all real numbers work. And this symbol here is belongs. This symbol here is the set of real numbers. This just says for every x that belongs to the real numbers, the function works and exists. The basic definition of domain, the set of all x's or inputs that are possible to plug in to the function, which would give the corresponding range, the set of outputs. Okay, now this is just one way of writing the domain. X belongs to the real numbers, okay? Now how about the range? The range we found, by looking down here, starting from 0, the function continues upwards. It goes to infinity, positive infinity, and down here is negative infinity. Right side is positive infinity, left side is negative infinity. So we wrote that the range is y greater than or equal to 0. So starting from 0 and including 0, so that's why we put this equal, greater than or equal to, and above, the function exists on the y-axis. That's the set of all outputs for this function. So all y that is greater than or equal to 0. So we found the domain, x belongs to real numbers, range, y is greater than or equal to 0. Great, but now, as I said in the beginning, we're going to go through notation, different ways of writing domain and range. Now if we look here on the x-axis, we have positive infinity and negative infinity. The same goes on the y-axis, positive infinity and negative infinity going down towards the negatives. Okay? Now, with this, what can we write? Well, we're going to start with something we call interval notation over here. Interval notation. From the word, we're going to deal with intervals on the x-axis for the domain and intervals on the y-axis for the range. Let's see here, all real numbers. How can we express that as an interval? Well, all real numbers on the x-axis basically means everything from negative infinity to positive infinity. So we would write that in interval notation, from negative infinity to positive infinity. Done. That's the domain in interval notation. Now how about the range? Let's see. It starts from 0 and goes all the way up to infinity. And we're including 0. It's part of the range. So how can we write the range in interval notation? Well, again, starting from 0 and all the way up to infinity, positive infinity. Starting from 0 right here and all the way up. Great. But now there's a difference here between the curly brackets and this edged bracket, as I like to call it. So the difference is that we're including 0 here. The function exists at that point. It's part of the domain. So we would put this edged bracket. For infinity, towards infinity, we put this curved bracket because infinity isn't really a number. It's not really included in the domain. It's not something you could plug in. Great. Okay, so this is interval notation. Now, what we wrote here with domain, saying x belongs to real numbers, this is more of what we would call set builder notation. And more formally, we would write it as follows. What we're saying here is that for all x, such that, or so that, x belongs to the real numbers, then the function would exist. That is the domain of the function. Okay, so for all x such that x belongs to the real numbers, that's the domain. This is set builder notation. Set notation. And with the range, And with the range, we wrote y is greater than or equal to 0, equal because 0 is included. This is what we're writing it as an inequality. Okay, so we have interval notation, we have set builder notation, and we have inequalities. Three main ways of writing the domain and range from a graph. Now let's go through another example. In this example, I don't really know how this function is defined. It's just a random function, but let's find the domain and range in all the different ways we learned to write them. First way, let's start with set builder notation. Let's look where this function exists in the x-axis. Where are all the possible inputs that would yield outputs in the function? Okay, so let's look at the x-axis. We see from -3 to 5, the function is there. So that's the domain. In set builder notation, we write all x such that x is greater than -3 and is less than or equal to 5. Notice how, even with the set builder notation, there are a number of things you could write inside this part of the set builder notation. Inequalities, sets, and so on. And so that's all good, but what exactly are we saying here? So this is an inequality. We're saying for all x that is greater than -3 and less than or equal to -5. Because here we see there's a filled in dot. That means that 5 is included in the domain and the function exists at that point. So we say x less than, here, less than or equal to. That equal to sign verifies that that point is part of the domain. And we wrote here near the -3 that x is just greater than -3, not equal to. Because this point is not included in the domain, because the function has a point that's not filled for x is equal to -3. It doesn't exist there. The function is undefined there. Great. Now how about the range? Well, for the range, we just look at the y-axis. Where is the function existing or occurring or whatever you like on the y-axis? Well, let's see, and let's use set builder notation. Y such that y is greater than -2 and is less than or equal to 4. The same idea. Now let's do this in interval notation. In interval notation, we would write in terms of intervals. What's our interval here? Well, from -3 to 5. We always start with the smaller number on the left and end with the larger number. So from -3 to 5. Curly bracket for the -3 because it's not included, and edged bracket for the 5 because it's included in the domain. The range, same thing, from -2 to 4. Great. So we've written inequalities within set builder notation, and we went through interval notation. Now, in recent math classes, you may have seen that we wrote inputs in tables and outputs as well in tables, or the range as a set of numbers, the domain as a set of numbers. That's all fine. We can write the domain and range as a list. If you're given, for example, a table, you would list the inputs, which would give you the domain, and you would list the outputs, which would give you the range. Same thing with the map. If we had 1, 2, 3 for the inputs, x, and the y's, we had 5, 6, 7, we would list these to be the domain. We would list these to be the domain and list these to be the range. Great. Okay, let's look at a final example. Here is what we call a piecewise function, because it's in pieces, 2 pieces, essentially. Let's find the domain and range with what we've learned. Let's start with interval notation. Let's look at where the function exists. Let's look at the x-axis. So we see around this -2 and then towards this -infinity the function exists. There is a part of the function there. And then right here, by 0 towards positive infinity, the function exists as well. Great. With that in mind, let's write these intervals. From negative infinity, not included, we don't include infinity, all the way up to 2, because at x is equal to -2, the function exists, it's included. And we start with negative infinity because it's the smallest, all the way up to 2. And then we see here from the 0, 0 is included, as you see on the graph, because we have a filled-in point, it's part of the domain, the function exists at that point, all the way up to positive infinity. But we're missing something here. We're missing a u. This u is called the union. It joins these two intervals, or sets. It joins them, combines them, unifies them to represent the domain as one. That's the basic idea you should know. Now let's look at the range. Interval notation again. If we look at the range, we see that, well, for the range we have to look at the y-axis, and we see from down here, which is again negative infinity, and all the way up to here, positive infinity. There's something going on. What exactly is going on? Well, we see, again, we start with the smallest, from negative infinity all the way up to here, which is -2, all the way up to here on the graph, -2, the function exists. Looking at the y-axis, -2 is included. And then we have this jump over here. This region is not filled. And we have a new interval. We don't look at this 3 over here. We look at this point over here. And we look at where the function starts. It starts, again, in this new interval on the y-axis, at this point here, which is 2. It goes from down here all the way up to this point, and then it starts again here. So this is going to be our new interval starting from 2. 2 is included. 2 all the way up to positive infinity, all the way above. Okay, we're missing again the union, to combine these two intervals and unify them to represent the range. Great. So that was it for today. So, thank you for watching. I hope you've learned about the different notation and learned from the examples provided. My email is below, send me any questions or suggestions, and you can find my blog in the description box as well.